So what page is this? Page 59. And we had done all of these, just identifying same side interior, same side exterior, alternate interior, alternate exterior, and then corresponding. All right, so we did that extensively. And then now, when we come down here, this looks similar to what we did yesterday. There's one big difference. So when we now look at this graph, as we jump in here, we still have two lines. So this I'm going to call line 1. This I'm going to call line 2. So we still have these two lines. And we still have what we call the transversal, and that is a line that cuts through those two lines. So in that way, it's the same thing we did yesterday. What is different about today, though, is you are told that the two lines that we're cutting through are parallel. And then that now introduces some new properties to us. The way we mark parallel lines, so if you look at these two black lines, line 1 and 2, I guess I have them J and K. See this little arrow right here on the line? And this arrow right here, that's telling you notation-wise, as we move throughout our geometry module here, that those lines are parallel. All right, so that's the marking that would tell us this. So now that we have these parallel, there are some different theorems that go with these. And you can see here there's 5, and it corresponds to the 5 things that we talked about yesterday. So the first one I'm going to do is alternate interior angles. So just write this down. So alternate interior, and I'm just going to use the notation for angles if I can get it to work. So alternate interior angles are, so remember what alternate interior angles are. Angle 4 and angle 5 would be alternate interior angles. Now this only applies, so this is really, really important to know, that in order for this to be true, we have to have parallel lines. That word parallel is pretty critical. But if they are, then your alternate interior angles are congruent. They'd have the exact same degree measure. Only if those two lines are parallel, which in this case they are. We also dealt with alternate exterior angles. So if I do alternate exterior angles, so in this case, let me get rid of the red, it's a little too dark. So angle 2 and angle 7 would be our alternate exterior angles. Alternate exterior angles are also going to be congruent. Then we didn't just have alternate interior angles, we had same side interior angles. So if we now look at a couple of those from this diagram, so if I did same side interiors would be like angle 4 and angle 6. They're inside those two lines. They're on the same side of our transversal. These guys are supplementary. So that means the sum of those two angles have to add up to be 180 degrees. Next one, we did alternate exterior. We also have same side exterior. Angles, that should be an R here, same side exterior. So for us in this problem, just to kind of refresh our memory a little bit on what our same side exterior angles would be, that would be angle 2 and angle 8. They're outside of the two lines. They're on the same side of the transversal, so same side exterior. Those guys are also supplementary. And then last but not least, the 5th property from yesterday, remember corresponding angles. These are already color coordinated for you. So the blue ones, 2 and 6, are corresponding angles. They're both the upper right-hand corner. The red angles, 1 and 5, are color coordinated. Those are corresponding. The greens and then the blacks. Corresponding angles are congruent. So as we move to this next page and we do some problems, and ultimately as you get to the homework and eventually as we get to a quiz, you need to know what type of angles you have. And then if they're parallel lines, we need to know, are they congruent or are they supplementary? And we want to just be able to keep all that stuff straight. So now as we jump to this next page, or at the bottom here, we'll talk about a couple of those to get these angles. So what's important to see is that notice in the directions, there's no mention of these lines being parallel. The way we know that these are parallel, however, is these arrows right here and right there. That's the notation geometry-wise that indicates we know those lines are in fact parallel. So because of that, we can now use those 5 properties at the top. So what we would want to talk about is, if I know this is 80, this is the one that I was given, and I am asking you to find this angle right here, what we first want to do is what we spent the entire period yesterday talking about, is identifying what those are. Are those alternate interior? Are they corresponding? Are they same side exterior? All that good stuff. So if we look at our 2 lines here, we would hopefully understand both of these angles lie inside of those 2 lines. So those are interior angles, both of them. There are 2 interior angle options, right? We have alternate interior or same side interior. If we look back at the diagram, here's your transversal. Notice how they are on the same side of that transversal. So what we just talked about, same side interior angles, so this is number 3, are supplementary. That means they have to add up to be 180 degrees. So if this is 80 degrees, wouldn't angle 5 then have to be 100 degrees? So that when we add them, we get the 180 that we're supposed to get. And I should put a little M right here because that's the measure of that angle. When we go to the next one, here are the angles I gave you to work with, angle 42 and angle 8. Here are our 2 parallel lines, the ones that have the arrows. So our transversal is now this guy. If we then look at the 2 parallel lines, this is the inside of our parallel lines. So when we start thinking inside or interior versus exterior, the 42 and the 8 are both outside of those lines. So these are exterior angles. We have same side exterior and we have alternate exterior. Well, if this is our transversal here, notice how the 42 is on the top side, the 8 is on the bottom side. So these are alternate exterior angles. So if we go revisit one of our properties up here, this one right here, alternate exterior angles are congruent. So since those are congruent angles, if that's 42, then we know the measure, come on now, of angle 8 must be 42 degrees as well. Then, like this whole packet, normally the first few we just give you numerical values, and then eventually we get kind of the algebra of this. And then that's what we have now on this next set of problems. But you're still dealing with all of those properties. So if you notice now, no mention of these being parallel, but when we see the arrow here and the arrow here, that's then our parallel lines. And then our transversal is the line that cuts through those 2 guys. So this then is the transversal. This then is the interior of those 2 parallel lines. Okay. All right. Let's do. How many of these problems do we have here? Did I give you? Let's do X first. See if you could figure out, how could we figure out what X is? So look at where there's 4 different angles labeled. The X angle deals with this angle right here. See if there's any thought process we could use to identify what X would be. Because there's a lot of different things in play right now, a lot of legit things, but a number of legit thoughts don't get you anywhere. So we want to come up with a legit thought that actually takes us someplace. All right, so now let's see where you're at. This is actually a little sneaky on our part because we just went through alternate interior, alternate exterior, same side exterior, and corresponding. So let's talk about some of those. Let's talk about these two angles right here. So the two angles that I have highlighted in yellow right now, those are inside and they're alternate interior. So don't necessarily write what I'm going to write down now. Don't write this down. But the two angles I have highlighted in yellow right now, those are alternate interior angles. Alternate interior angles are congruent. So we could say that 3x minus 6 equals a 2z plus 2. But notice how that doesn't do us any good because there's multiple variables there. So while this is a very much a true statement, this is not a wrong statement, to start with that idea doesn't get us anywhere. So that's not going to be where we want to go. Well, this guy here, as well as the other yellow highlighted angle, those are same side interior angles. We have a property for those. Same side interior angles are supplementary. So we could say that 3x minus 6 plus 13y plus 8, that added together have to equal 180. That is a true statement, 100% true. But the fact that you have multiple variables in this doesn't do us any good. So while that's a true statement, that's not what we would want to start with. I think Ahmed in here said the right thing. Did he, Mr. Goodwitz? Did he tell you that? What's that? Okay. What can we do here, Ahmed?
Well, at first I thought these two were
Good. So what he said is, if we use the angles that are across from each other, so this 3x minus 6 and the 42, remember from last quiz that we took, our idea of vertical angles, we talked about this yesterday again. Those are still very much relevant. These are vertical angles. And what we know is vertical angles are congruent. So what we want to start with to get that x is that 3x minus a 6 would have to equal 42 degrees. That then now is good. We can solve this for x. So 3x is equal to 48. Divide by 3. And we find that x is 16. All right. Now we need to go through, figure out some other way to kind of go through this. If we now know that this is written as an expression, but isn't this now also a 42 degree angle? So we know this angle right here has to be 42 degrees. Now the things that I talked about before open up to us. So let me make this a little more clear. So I'm going to cross out the 3x minus the 6. Not that we have to do that, but I now don't have to worry about this in terms of a variable. I actually know this is a 42 degree angle anymore. I don't have to worry about that as a variable. So now those things that I was talking about before, now these become much more in play. Where we could now say that 42, and we'll just go in order. We'll do the y next. 42 and 13y plus 8, those are same side interior. And if you go back to your properties, same side interior angles are supplementary. So that means if I took the 13y plus an 8 and then add that to 42, those angles add together must add up to equal 180. All right. These we should be pretty good at this point, these equations. So combine your like terms, subtract the 50 over, and we find that y is a 10. So now that allows us to do is to say what this angle would be. We also could have said what this, I guess there's a lot of different ways we could have done this, right? Even this over here, we can talk about if this was 42, just let me make sure. So if you had this thought, and these are supplementary, didn't this big angle here have to be 180 minus 42? So this would have had to have been a 138 degree angle, right? So you also would have been perfectly fine saying 13y. So watch how this would play out. Plus that 8 would have to equal 138. And notice when I go to solve this, won't that also give me a y value of 10? So that would have been a perfectly valid thought as well. Okay, so many different ways you can kind of go about that. We could have said, if this is an alternate x, this 42, this had to be 42, right? Because if that's 42, these are alternate exterior angles. So those are congruent. And then we could say these are supplementary. A lot of different routes you could take here. All right, do letter D now. So do letter D. Or I'm not D, Z. So find letter Z. However you think you would go through that. Because there's really all kinds of ways. I mean, just about every theorem is in play right now. It is hard not to give me one of the 6 theorems and say that one of them is valid. All right, Cam, what do you got? What are you setting up to get that one, Cam? Good. So what Cam is using is, how do I want to do this? The alternate interior angles here, this is 42. And this here is its alternate interior angles. So the 42 and the 2z plus 2 must be congruent to each other. Okay. Solve that. And we get z to equal 20. Couldn't we have also have done z at the beginning as well? Like we went in alphabetical order, x, y, z. But couldn't we have used this angle here, the 2z plus 2, and the 42, because aren't those same side exterior angles? And don't we get the same exact equation that Cam just gave us? Same side exterior congruent, so we would have taken this 2x plus 2. You would have been setting it equal to this angle to equal 42. That would have worked as well right from the beginning. Okay, so a lot of different thought process with these are going to work. So for which one? Okay, and then what Mr. Kubowitz just said is once we knew that this was 38 or 138, that we have a linear pair right here. So what he was saying is, I don't know why that's so purple. 138 and 2z plus 2, this angle that we're looking for, plus 138, that had to equal 180 because that formed a straight line. All right, so really a lot of different ways that you can approach this. So with that in mind, I'll give you 2 minutes here. Come up with these guys. See what we think. It's the last one, I think, and then we might do a homework problem more too. Yeah. Let's see what we come up with. See if you can get angle A, angle B, and angle C. Anything we've done comes into play now. Like we've used we've used vertical angles today. That wasn't part of the new stuff yesterday. Mr. Kubowitz just threw out the idea of a linear pair. That's an old idea that we've already quizzed on. And then certainly the new 5 theorems are also going to pop up. And there are, the first route is nice. Everyone's going to do that the same. But to get the other 2 variables, there's a couple different ways you could go. How are these guys doing? Okay, good. That's what I'm going to guess most people do. Yeah. let's see where we are at here. Yeah. Cam, what did you do first, Cam? You do that? Why did you do that? Like, what was your reasoning? Nope, that's exactly what I was looking for. Nope, you said it perfect. So what he did is he looked at this triangle right here, and he knew this triangle had to add up to be 180 degrees. So it's the old idea. We quizzed on it last week. 65 and 40, take that away from the 180. So what he said is, I'm just going to take the 180 that I know is involved in the entire triangle. Let's subtract away these 105 degrees that I have in the other two angles. And then what'd you get, Cam? This had to be a 75-degree angle. So I now know this is 75. That's what everybody here did as well. So I'm guessing a lot of us at home looking at that, that's probably the most obvious. We have a nice triangle there. We've already quizzed on it. It's a pretty nice one. I think everybody knows. All right. Anybody then work their way to the A or the C? Yeah. What'd you do, Cam? Oh, I really like where you're going with that, Cam. Because so it definitely is an alternate interior angle. Gavin can help him out there. He's right in one way, but what are the alternate interior angles, Gavin? Think good. A, Cam, is going to be the 65. So let's do this one first. So Gavin gave us both of them. Let me show how we got this one. So here are my parallel lines, right? And then here. And then I'm going to draw in the transversal here. So it's hard, but kind of ignore this line. Can I click on this line? No, it's a full triangle. Notice how now, Cam, see the transversal and our parallel? Is it easier to now see that A, okay, good. So A is an alternate interior angle, so that's great, but it's an alternate interior angle with 65. So that's why A has to be 65. And then what Gavin said is C is also an alternate interior angle, but let's now look at the other transversal, because now this line would also act as a transversal here. And then when we look, 40 and C are alternate interior angles as well. So that's where he got that the C would have to equal 40 degrees. All right. Yeah, good, both of you. All right, so that's where when we've been warning you a little bit, we keep adding layers to this, and you got to kind of remember all of them. So alternate interior, the triangle, linear pair, vertical angles, all that stuff still coming back. All right, so what we're going to do, your homework are the next 2 pages here. What I'm going to have you do, go to the very last problem. Let's kind of just work our way through this together. It'll be a nice test of a lot of things. So if you look at that mess of a graph, got a lot of things going on there, a lot of different angles, and all we gave you was 42 degrees. So right away, write down, when I look at that right now, and I'm obviously a math teacher, you're supposed to know this very quickly, but when I look at that, there are 3 angles that right away I can say the answer to. All right, so write down whatever comes into your head here. So we have plenty of time to spare. I'm going to give you 2 minutes. I'll give you to 9:58. Fill in whatever we can fill in based upon what you are looking at right now. you're completely lost as we kind of get into our last minute, the ones that I think, these are old ideas. Angle 1, angle 2, angle 3, and angle 10 are things you've already quizzed on. It's what we quizzed on last week. Some of us are retaking now, but those are old ideas from last week. Those would be the ones when I said I look at it and can come up with some very quickly. Those would be the ones that I would hope we could look at because we've already quizzed on it. We've already done homework on it and be able to come up with at least those 4. And then if you can keep going, then just keep on cranking them out. All right. I feel like that was a fast minute. We'll give you 30 seconds here. I think it was like 9:56:45 when I said that. All right, where could we get going here? What are some of these angles? As these dominoes start to fall, being able to get a couple should lead us to a few more. We should be able to kind of work our way around that whole graph. All right, Cam, what'd you come up with first? So Cam said the measure of angle 10 is a 90-degree angle. How'd you know that, Cam? Yep. And it is in math teacher talk, this box 90 degree and the 10 is what we would call a linear pair. They make this straight line. So these have to add up to be 180 degrees. So 90 and 90, that's got to be a 90-degree angle. Alexandra, you got a different one? Good. So she has angle 2. Let me actually mark in the 90 here. And then what do you have for angle 2? Good. And how'd you know that? Good. They're across from each other, formed by 2 lines. Those are what we call vertical angles. Vertical angles are congruent. All right, so those are 2 of the 4 that I would hope we can get pretty quickly. All right, what's another one? Jenna? Good. So she said that angle 1 is 138 degrees. So let's mark that in. How did you know that, Jenna? Good. So same thing that Cam used where this is a line right here. So this is a linear pair. So these have to add up to be 180. So she did 130 or 180 minus 42 gives us 138. And then once we know that one, go ahead and finish that one, Jenna. Now what's that give us as well? Good. Now these are the vertical angles that Alexandra gave us for 42. These are also vertical angles. Now we know this has to be 138. So angle 3 is 138 degrees. So those are the ones that are older. We did those in the first couple sections of this chapter. But now we need to get our way to 4, 5, 6, 7, 8, and 9. Did anybody get to those? Get any of those? You got all of them? What'd you do first, Ahmed? Good. So what Ahmed just gave me here in school is 42 degrees. How'd you get that, Ahmed? Good. So what he used, notice these arrows right here? Darn it. Let me erase that real quick, hopefully. Yes. These arrows and these arrows are telling us that these 2 lines are parallel to each other. And then what we have is a line that cuts through both of them. So this is our transversal. So this is now the new stuff that we've spent the last couple of days on. And what he used was 138 and 4 are same side interior, and same side interior angles are supplementary. So what he did is he took 138, subtracted that from 180, and then that gave him angle 4 to be 42. So that's Ahmed's thinking. I'm more of an alternate interior angle guy. So I probably would have looked at, see here, this transversal. Notice 42 and 4 are alternate interior angles. That would have given us this 42 as well. All right, so different routes we can take with this. All right, the next ones get a little sketchier. You said you had some more, Ahmed?
Yeah, I have number 5 too.
All right, how'd you get number 5?
The one that I got from number 5 is 90. Because I used a different coordination number 8.
How did you get number 8 then?
8 also.
How do you know that?
It's the same side interior.
Okay, good. So now, what he did actually next, while he didn't realize it, he found angle 8 next, and it is 90 degrees. Don't say just because it looks like 90 degrees. Good. So we have another transversal. If I can get a different color to work here. The pen's freezing. We're running out of time. Oh, there it is. There it is. It's a good place to stop anyway, right? This is your homework. So I'll leave you those last couple. But basically what he figured is the 8 has to be 90 degrees because we have another transversal going straight up and down. And 8 and 90 are same side interior. And then that gets you then started on all those other angles. Okay, but you can see Word is not responding for me right now. So we'll call that a day. We got a minute to spare. But that's your homework. Oh, there it is. So just have those done for tomorrow night. If there's any questions, we can talk about it. You may have some questions tomorrow, and if you do, we can talk about that at the beginning of class. All right? Okay, we'll see you guys. Have a good day. Yes, sir. Yeah, just send it to me. Yeah.